Good morning. We are going to make a final revision for the science. We will start first with the chapter 1 or unit 1. It includes the chemistry part, which is the chemical reaction. Chemical reaction first, its meaning is we know that in any chemical equation there is a reactant first and the product second. For example, if we have a chemical reaction like that, calcium hydroxide here, the reactant, and copper hydroxide here is the reactant, copper oxide and water are the products. So any chemical equation consists of reactants, products, and the condition of the reaction. Breaking down of the all bonds between the molecules of the reactants and the formation of new bonds between the molecules of the products, this is the meaning of the chemical reaction. Again, breaking down for the all bonds between the molecules of the reactants and the formation of new bonds between the molecules of the products. We have three different types of chemical reaction as titles. Number one, the decomposition reaction. Exactly the thermal decomposition reaction, which is meaning the decomposing of the compound by the effect of heat into its components. First, we have 5 chemical equations. In this meaning, the first one, the decomposition of the red mercury oxide. Mercury oxide is HgO, decomposes by heat into the mercury oxide and the oxygen. We will see that there is changing in the color of the mercury oxide from the red color to the silver color if it is decomposed by heat due to decomposing it into mercury, which is silver in color, and oxygen. The second one, or the second equation, is the decomposition of copper hydroxide. Copper hydroxide has a blue color, but if you are going to heat it, it decomposes by heat into copper oxide, which is black in color, and water vapor. In this case, there is a changing also in color from the blue color to the black color due to decomposing the blue color, which is the copper hydroxide, into black color, black color, which is the copper oxide. The third one is the decomposition of the green copper carbonate. Copper carbonate here has a green color. If you decompose it by heat, if you heat it, if you are heating it, it will decompose into the copper oxide, which is black in color, and carbon dioxide. The fourth one is the decomposition of the copper sulfate. Copper sulfate, CuSO4. Copper sulfate is blue in color. It decomposes also into copper oxide, which is black in color also, as the equation before, and the sulfur trioxide. The last one in the thermal decomposition reaction is the decomposition of the sodium nitrate or potassium nitrate. It decomposes into the sodium nitrite and oxygen. Take care that the sodium nitrate compound has a white color, but after decomposing it by heat, it will give the yellowish white color due to the formation of sodium nitrite. See the difference in writing it. This is a sodium nitrate, this is a sodium nitrite, and evolving the oxygen. These are the decomposition of the all compounds that you have: mercury oxide, copper hydroxide, copper carbonate, copper sulfate, sodium nitrate. 5 chemical equations in the thermal decomposition reaction. And the name of the compound will give me the secondary product plus the metal or the copper oxide. There is one important application on the thermal decomposition in the case of the airbag or safe bag. This occurrence during the car accidents or during crashing of the cars due to the rapid composition of the sodium acid Na and 3 nitrogen and sodium decomposes as soon as the crash occurs. It will form directly sodium and nitrogen. Nitrogen gas will fill the airbag to save propulsors and protect the driver from any injury. This is the only one application. The second type, I said first, we have 3 different types of chemical reactions: thermal decomposition, substitution reaction, oxidation reduction reaction. The second one is the substitution reaction. Substitution reaction, we have 2 different metals. One of them is more active than the other, or we have a hydrogen and metal. One of them is more active than the hydrogen, so it will replace the hydrogen in its solutions or in the acid in case of the hydrogen. This depends on the chemical activity series of the elements, CAS, or the chemical activity series, the arrangement of the elements in descending order according to their chemical activity. And these chemical activity serial: potassium, sodium, barium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. This is the chemical activity series. Each element before the other elements of the chemical activity series more active than it, and they can replace it in its solution. These elements, the arrangement of it will define if this reaction can take place or not, if it's more active than it or not. The first type is the simple substitution reaction. In the simple substitution reaction, we have to know the replacement of element instead of the hydrogen in the water. So here the sodium react with the water. Sodium is going to replace the hydrogen in the water, forming the hydrogen sodium hydroxide and evolving the hydrogen gas that burns with a pop sound. And this exothermic reaction includes evolving of heat. Here is another element or another metal can replace the hydrogen in the chemical activity series, which is the zinc. Zinc replaces the hydrogen of the acid. Zinc plus HCl acid, hydrochloric acid. Zinc before the hydrogen in the chemical activity series, so it is more active than it, so it can replaces the hydrogen in the acid, forming zinc chloride and evolving the hydrogen gas. Also in the case of the aluminium, aluminium react with the diluted hydrochloric acid after a short time, but more strongly than zinc, which react immediately forming the aluminium chloride and hydrogen gas. Also because the aluminium is more active than the hydrogen, so it can replace it in the acid, replace the hydrogen, I mean. But what about the elements that after the hydrogen, the chemical activity series, such as the reaction between the copper and hydrochloric acid? Copper less active than the hydrogen because it is after the hydrogen, the chemical activity series, so it cannot replace it. So there is no reaction in this case because the copper after the hydrogen, the chemical activity series, so cannot replace it in its solution. Another kind of the simple substitution reaction, which is the replacement of element instead of another element, not the hydrogen. This also depends mainly on the arrangement of the elements in the chemical activity series. We have here magnesium react with the copper sulfate. We will see if the magnesium is more active than the copper or not, if the magnesium is before the copper or not in the chemical activity series. If it before it, so it can replace it. So magnesium instead of the copper, and the precipitation of the reddish brown of the color of the copper color due to the replacement that happened magnesium instead of the copper. The second type of the substitution, the double substitution reaction. Double substitution reaction, you have two compounds. Each one of them consists of two ions. Positive ion, the first one, and the negative ion, the second one. The first type of the double substitution reaction, we will see that there is an exchanging of ions between the two compounds in the reactants, forming new two compounds in the products due to this exchanging of the ions. The first type in the double substitution reaction is the neutralization reaction. Neutralization in chemistry generally is the reaction between acid and alkali forming salt and water. We know that the acid is containing a hydrogen positive ion, while the alkali is containing hydroxide negative ion, OH negative. So the reaction will be HCl plus NaOH. The positive, the first one, which is the hydrogen, will take the OH, the negative ion of the second one, forming the water. And the negative of the second one will take the positive of the second one, negative the first, will take the positive of the second one, forming an NaCl. That's meaning that this is a double substitution reaction. At the same time, it is a neutralization reaction, acid alkali forming salt and water. Another reaction is between acid and salt, but only one salt you have it, the salt of carbonate. Here is the reaction between acid, HCl, hydrochloric acid, and the salt, which is the carbonate, which is Na2CO3, forming also salt and water. But because the salt here is carbonate, it will evolve the carbon dioxide gas. The last one in the double substitution reaction is the reaction between two salts. And the two salts you have during this time is the sodium chloride NaCl plus the silver nitrate AgNO3. Positive, negative, and then make the exchange of the ions between both of them, so it will form the sodium nitrate and silver chloride. Silver chloride in this case is a solid substance, will precipitate in the color white. This is the double substitution reaction, exchanging of the ion, forming new two compounds. The last one of them is the oxidation reduction reaction. Oxidation reduction reaction, two chemical process will take place on the same chemical equation. If we are taking very important example, which is the reaction between the hydrogen and the copper oxide, we know from the chemical equations before that the copper oxide is black in color. The reaction between the hydrogen and the copper oxide, this black color will disappear and change it into the reddish brown color of the copper, plus the water. What is the difference between the hydrogen and water? That the hydrogen, oxygen is added to it. Changing the hydrogen into water is called oxidation. Why? Because the oxygen is added to it. Adding oxygen or removing hydrogen, this is the meaning of oxidation. And the substance that oxidizes is considered a reducing agent. So that's meaning hydrogen here is a reducing agent. It is the chemical substance that takes oxygen or remove the hydrogen. The second one is changing the copper oxide into copper by taking the oxygen from it. Taking the oxygen from the substance is called reduction. So copper oxide is reduced and changed into copper. This process is called reduction, and the copper oxide is oxidizing agent. So the copper oxide is the substance that gives oxygen or takes hydrogen. Here, the second explaining of the oxidation and reduction according to losing and gaining of electrons. If we have the sodium atom, its electron configuration is 281. That's meaning it contains one electron, the outermost energy level. During the formation of the compound or the chemical reaction, it must lose one electron and change into sodium positive ion. This process is called oxidation. That's meaning we have another meaning of the oxidation, which is losing one electron or more. And it occurs always in case of the metals, because the metals are the elements that will lose. Here is the chlorine atom. The chlorine atom is, its atomic number is 17, and its electronic configuration is 287. Then it will gain one electron and changing into chlorine negative ion, and this gaining of electron is called reduction. So oxidation is losing one electron or more, reduction is gaining one electron or more. The substance that lost one electron or more is called reducing agent. The substance that gained one electron or more is called oxidizing agent. This is the first part. The second part is the speed of chemical reaction. Speed of chemical reaction is the change in the concentration of reactants and the products per unit of time. And we have a different example for the reactions that takes place slowly or fast or whatever. Here, it is the change in the concentration of reactants and the product per unit of time. This is the meaning of speed of chemical reaction. Changing the nitrogen pentaoxide into nitrogen dioxide and oxygen. This is a decomposition also, breaking down of the nitrogen pentaoxide to give two gases here in the graph. At the beginning of the reaction, the concentration of reactant supposed to be 100% and the product equals 0. At the end of the reactions, the concentration of the reactants equals 0 and the concentration of the product is 100. In this case, that's meaning this line will represent the nitrogen dioxide. This line will represent the oxygen. But here the concentration is high and becomes low. That's meaning, and this is the product. Okay? Here we have group of factors affecting the speed of the chemical reaction. These factors, number one is the nature of the reactant. The nature of the reactants includes two factors, which is the kind of bond and the exposed surface area. We will talk first about the kind of bond. We have two different kinds of bonds. One of them is the ionic, the other is covalent. If it is ionic, the reaction will be fast because it takes place between the ions. If it is covalent, that's meaning the reaction will be slowly, because it takes place between the molecules, not between the ions. This is the kind of bond between the reactants molecules. Number two, the surface area. If the surface area increased, the reactant molecule increased, the speed of the reaction increased. That's meaning if you have a zinc powder and the zinc piece, the reaction in the case of the zinc powder will be faster with the hydrochloric acid due to increasing the surface area of the reactant molecule, I mean the powder. Ionic bond, for example, reaction, we took it in the double substitution reaction between salt and salt, the reaction between sodium chloride and silver nitrate. This will take place instantly at the same moment of the reaction. The reaction between Fe and HCl, one time in the case of the powder and the other time in the case of zinc piece, the reaction between iron and the hydrochloric acid. And we took that one before also. The combustion of the scurrilous, and the presence of oxygen. This is a pure oxygen. This is the atmospheric oxygen. The pure oxygen, high concentration. The atmospheric oxygen, lower concentration. That's meaning the concentration is an important factor, affects in the speed of the chemical reaction. So if the concentration increase, the reactant molecules increase, the speed of the chemical reaction will be increased and the reaction will be faster. This is why we have to put the food in the refrigerator to protect it from spoiling, because we're just reducing or stop the reaction of the food due to decreasing the temperature with the reactant molecules. That's meaning and the temperature is very important factor, effects on the speed of the chemical reaction. How? If you are heating the reaction, increasing its temperature, I mean, it will gain a kinetic energy, so it will move faster. So the rate of collision will be increased. This will increase the speed of the chemical reaction because they will reach faster to which is called activation energy. Increasing temperature, increasing concentration, increasing the surface area, ionic bond. All of this increasing the speed of the chemical reaction. What about the catalyst? The catalyst, the substance used to change the rate of the chemical reaction without itself being changed. Yani entering the reaction, it will not change in its nature or in its composition. We have two different types of catalyst, which is the positive catalyst and the negative catalyst. Positive catalyst speed up, increasing the speed of the chemical reaction. Negative catalyst slow down the chemical reaction. For example of the catalyst is the decomposition of the hydrogen peroxide H2O2. Hydrogen peroxide normally decomposes and gives oxygen before adding the catalyst even, but the reaction will be slower and will give small amount of oxygen. But if we add a substance called manganese dioxide, the reaction will be very fast and the amount of oxygen will be large. That's meaning the catalyst speed up the chemical reactions and give me the products in a very short time. The properties of the catalyst change the speed of the chemical reaction without itself being changed. No chemical change in its mass or in its color of the catalyst before or after the chemical reaction. They are bonded to the reactant molecules and then separating from them quickly to form the resultant at the end of the reaction. Decrease the activation energy of the reaction, or decreasing the amount of energy needed for the reaction, usually used in small amount. This is the catalytic converter. Metallic can exists in most modern cars to treat the harmful gas and changing it from less harmful into more harmful. It takes this shape and the kind of metal inside it will be the platinum or palladium. The electric current, we have to describe the electric current, the second unit, we describe the electric current by three different things. Number one, by the current intensity, potential difference, and the electric resistance. The current intensity, potential difference, and first we will have the relation between the electric current intensity and quantity of electricity on time. Here I is the quantity of electricity passing through cross-section of a conductor in 1 second, so I equal Q over T. I is the current intensity, Q is the quantity of electricity, T is the time. If you have another triangle to see what are the units for measuring it, the quantity of electricity is measured by a unit called coulombs, while the current intensity is measured by a unit called ampere, while the time, of course, by using the second. This is the first one. The I equal Q over T, or the current intensity equal the quantity of electricity passing through cross-section of a conductor in 1 second. And this one is measured by an instrument called ammeter, and this ammeter is connected, it's shaped like that, and it is connected in series in the electric current. This is the first description. The second description, is by using the potential difference. Potential difference, its symbol is V, and it is the work done in joule to transfer quantity of electricity in coulomb. So V equal W over Q, or to the work done to transfer the quantity of electricity. If you have a triangle like this, by the unit work by using the joule, this is by using the volt, and this is by using the coulomb. This is the second description of the electric current. Again, the potential difference is V equals the work done in joule to transfer the quantity of electricity in coulomb. So V equal W over Q. To measure the potential difference, we use a tool called voltmeter. And the voltmeter, its symbol is V, and it is connected parallel in the electric circuit. This is the second description. The third description is the electric resistance. Electric resistance, its symbol is R. R will be one of two. This is the obstruction that the electric current will find during its flowing in the wires. It will be in the form of fixed resistance in the electric circuit like this, or it will be in the form of variable resistance, and it will take this shape. This variable resistance, very important in the exams. Variable resistance called rheostat. Rheostat, or the variable resistance, is used to control the length of the wire and controlling the current intensity and potential difference. If you are controlling the length of the wire, you will control the electric resistance, and then you will control the current intensity and potential difference. That's meaning we have two factors affecting on the value of the electric resistance: length of the wire, and the length of the wire is directly proportional with the electric resistance. The first factor is the length of the wire affecting the electric resistance. The length of the wire is directly proportional to the electric resistance. Increase, increase, decrease, decrease. The second factor is the cross section of the wire. If I have this cross section, another one I have this cross section, this is inversely proportional. Inversely proportional with the electric resistance. Increasing the cross section, decreasing the electric resistance. These are the two factors affecting on the electric resistance. If you collect what is the relation between the electric resistance and the potential difference and the current intensity, they will be collected together, in which is called Ohm's law, or equal V over I. And this is the battery, and then the key, and here will be the ammeter to measure the current intensity, and then this is the rheostat, and then the fixed resistance, and then with it we will connect it with the voltmeter to measure the potential difference. This is the electric circuit that verified Ohm's law. Ohm's law state what? The current intensity is directly proportional to the potential difference between cross-section of a conductor at a constant temperature. And if we are going to make this one by using the unit, this will be, for measuring it, is the volt, this one is the ohm, and then this one is the ampere. So the volt is meaning it is the potential difference when the electric resistance is 1 ohm and the current intensity is 1 ampere. While the ohm is meaning what? Ohm is meaning it is the electric resistance when the potential difference is 1 volt and the current intensity is 1 ampere. This is the relation between all of them. Just also take care about the difference between the EMF and the potential difference. EMF and the potential difference is the EMF, or EMF is the potential difference when the electric circuit is open. When the electric circuit is open, this will be EMF, electromotive force. Electromotive force is measured by voltmeter, and the unit for measuring it is the volt. If we have 3 cells, and these 3 cells will be connected in series, I'm going to connect the positive of the first one is connected with the negative of the second one. Positive of the second one will be connected with the negative of the second one. Positive of the third one will be connected with the negative of the first one. Disconnected to, if you want to get the EMF of the battery, equals EMF of the first one plus EMF of the second one plus EMF of the third one, or the EMF of one of them times the total number of them. These, if you are going to connect a group of cells in a series connection. But if you are going to connect these cells in parallel, you have to connect them. All the negative poles are connected together in one point, and all positive poles of the cells are connected in one point, and the EMF of the battery equal EMF of one cell. In this case, this is called the series connection, and this is called a parallel connection. And of course, don't forget to compare between the alternating current and the direct current. Alternating current, this is the current that produced from the dynamo. Direct current produced from the batteries or electric cells. Alternating current changeable, not constant in intensity and direction, while the direct current is constant in intensity and direction. Alternating current can be changed into direct current, while the direct current cannot be changed into alternating current. The alternating current can be transferred through a long distance, while the direct current is not. Don't forget to compare between, or to know what are the comparing between both of them. I hope that you understand correctly what I explained, and I wish you have a good exam and you answer it completely. Thank you.